All right, excuse me, IBAASL2. Today we're doing definite integrals, which means that there's like a start and a stop point on it, but we're mixing a little U substitution up in the mix. This first example we're going to do is not actually with the U substitution. It's just kind of a definite integral that involves trig, since a lot of us are rusty with the trig, so we're going to throw some more in there from time to time. Remember, if you're going to do a definite integral, you first have to find the antiderivative of whatever is in between the integral symbol and the dx. So that 3 is really just a coefficient that comes and hangs out on the outside. So then the antiderivative of... Did the book make a mistake? I think they did. Oh, no, they didn't. So antiderivative of sine is negative cosine. So this becomes negative 3 cosine x from pi over 6 to 0. Remember from last lesson that it's always the top thing plugged in minus the bottom thing plugged in. So this whole thing is negative 3 cosine pi over 6 minus 3 cosine 0. Now, if you're rusty with the trig, I always just draw a unit circle off to the side, and then I fit in whatever triangles I'm looking at. So if we're looking at pi over 6, that's a 30, 60, 90 right here, and the cosine value would be root 3 over 2. So this is negative 3 times root 3 over 2. And then the cosine of 0, if you look here, 0 is a very skinny triangle that hits right here, and the cosine is the base of that. So that's a positive 1. So this is negative 3 times 1. Notice I am not touching a calculator for any of this. The expectation is that you guys know parts of the unit circle and do not need a calculator to find sine and cosine of certain parts. So then, if I clean things up here, we get negative 3 root 3 over 2 minus 3. Then we need to create a common denominator there. So we get negative 3 root 3 over 2 minus 6 over 2. So this whole thing equals negative 3 root 3 minus 6 all divided by 2. Oh, you know what? I messed up a tiny bit. When I plugged in the second part here, I forgot that you have to subtract, and there's a negative 3. So, like, here. It will be minus negative 3 times 1 here, which means this will be a plus 3 and a plus this. So we get that. Next up, now we're going to do a definite integral, but we're going to actually use U substitution. So we know that this is a U substitution problem because there's an inside function. So straight off the bat, we're going to say U is equal to 3x squared plus 1. And then we'll go ahead and find our du dx, which is 6x. That's good news because the 6x is evident in the problem. It's right here. So this 6x dx will get swapped out for u. Now, you guys, here's the problem. If I go to swap out and put everything in here, so let's go ahead and start to swap out. We're going to do u cubed du because all of this is du. Now, the problem is this number and this number can no longer be 0 and 1 because these need to be, and I'll make a note about it here, these need to be in terms of our new u. So here's what you do. You plug in those numbers into this right here. So we need to find u of 1, which is 3 times 1 squared plus 1, which is 4. And then we need to find u of 0, which is 3 times 0 squared plus 1, which is 1. So when you put a 1 in, you get out a 4 in the u equation. When you put a 0 in, you get out a 1. So those are the numbers that need to get replaced into these spots right here. So this will be 4 This will be 1. So we're no longer going from 0 to 1. We're going from 1 to 4. Then you can take your integral, that this will be 1/4 u to the 4th from 4 to 1. Then you plug in the top thing minus the bottom thing. So this will be 1/4 4 to the 4th minus 1/4 1 to the 4th. Now if I start to clean that up, 4 to the 4th, what is that, 64? No, it's bigger, 256. So 256 divided by 4 is 64. So this whole thing is 64 minus 1/4, because 1 to the 4th is just 1, so this is 64 minus 1/4. Then 64 in terms of fourths is 256, and we're kind of, I guess I could have just left it as 1/4. I actually just did extra work there. 256 quarters minus 1/4 is equal to 255 quarters. Make sure the book agrees. They do. Sweet. So that's your answer. Remember, the main point of this is that you have to change these right here into, you have to put those numbers into the u equation that you came up with to come up with the new limits, which are here. Next up, we're doing u substitution with some trig mixed up in there. So first thing you need to think of, this sine squared, x is the same thing as sine of x squared. So this is the function that is inside another function, so that is your u. You can say u is equal to sine of x. Then the derivative of that du dx is cosine x. So du is cosine x dx. That's good news because I see a cosine x dx right here. Those are going to get swapped out for du. Now, the one thing I haven't done yet is rewrite these guys in terms of u. So we're going to have to plug both of those into u. So u of pi over 2 is sine of pi over 2. If you're rusty on that, once again, draw your unit circle. Pi over 2 is up here at the top, so that is a very skinny triangle that's all height, no base, so the sine value is 1. Then we also need to find u of pi over 4. Pi over 4 is this triangle right here. It's a 45, 45, 90, where the sine value, so sine pi over 4 is equal to the square root of 2, square root of 2 over 2. So there's our new limits, our new sort of start and stop points. So if I go to rewrite this whole integral, the top is now 1, and the bottom is root 2 over 2. The cosine x dx just becomes du, and this whole part right here is just u squared. So this becomes u squared du. Take the antiderivative, and you get 1/3 u to the 3rd from 1 root 2 over 2. Now plug those in, and we get 1/3 1 to the 3rd minus 1/3 root 2 over 2 to the 3rd power. Now this part just becomes a big 1, so we don't have to worry about that. What else do I want to talk about in here? Should we smush it all together? No. Okay, so this becomes 1/3. And then root 2 cubed, I'm just going to leave as root 2 cubed, but this becomes root 2 cubed all over 2 cubed is 8, and 8 times 3 is 24. So this becomes 24. Now, you guys, root 2 cubed over 24, if I rewrite this, we'll just let the 1/3 hang out. Root 2 cubed is root 2 squared times root 2 all over 24. Now the root 2 squared is 2, so this whole thing becomes 1/3 minus 2 root 2 over 24. And then the 2 over 24 can be reduced to a 12th. So we'll have to continue right here. This becomes 1/3 minus root 2 over a 12th. Then you need common denominator between the 3 and the 12. So this will become 4/12 minus root 2 over 12. So the final answer after all that work is 4 minus root 2 over 12. There's the entire problem. Next up, this looks like another u substitution where the inside is 1 plus 2x cubed. So that's going to be our u right off the bat. That u equals 1 plus 2x cubed. So then du dx is going to be 6x squared. Now, it's good that I see an x squared in there, but I don't see a 6. So we're going to have to rearrange things here to say that du dx, this would be 6x squared, but we need x squared dx, so we would have to multiply by a 1/6 on both sides. The next step is to put in the endpoints into the top and bottom, or into the u function. So here, we're going to put in u of 1 equals 1 plus 2 times 1 cubed, which is 3. And then u of 0 is 1 plus 2 times 0 cubed, which is 1. Now you can rewrite the whole function, where this is 3, this is 1. Oh, we need to put a 1/6 on the outside because of 1/6 du being here. And then this whole thing becomes u to the 5th du. Then we take the antiderivative. This becomes 1/6 u to the 6. Oh, and there's going to be a 1/6 on the outside. So we're going to have double 1/6. I should rewrite that. Yeah, let's just... So there's the first 1/6 is this guy. Then there's another 1/6 when you do your antiderivative power rule. So this is 1/6 u to the 6. Then the whole thing goes from 3 to 1. These two multiplied are 1/36. So I'm just going to go ahead and do that. And then we'll get 1/36 u to the 6, a 3 to the 6th. And then take away 1/36, 1 to the 6th. Now if we start to clean this up, well, they're both 1/36. This part will just go away. That'll just be a 1. So it's really like 3 to the 6th minus 1 all over 36. Now 3 to the 6th is 729. I definitely did that with a calculator. I wouldn't expect you guys to know that offhand. And then this will be 728 over 36, which I think, yeah, there's at least a 2 that comes out of all that. So use that good old answer to fraction button and get 182 over 9. Here's that entire problem. This one is kind of tricky because your u is the square root of x, so u equals root x, which means du dx is equal to 1/2 out in front, u to the negative 1/2 when you subtract 1. Now, you need to recognize that u to the negative 1/2 is the same thing as this. So the inner derivative, the derivative of the inside is present. The one thing I don't see is the 1/2. So we're going to have to engineer the 1/2 and say 2 du is equal to u to the negative 1/2 dx. Then we're going to plug in u of 4 equals square root of 4, which equals 2. And we'll do u of 1, which is the square root of 1, which is 1 again. So when I rewrite this whole thing, we'll get from 2 to 1, and then just e to the u. Oh, I forgot the 2. The 2 we have to engineer. So that 2 will go on the outside, du. Then the antiderivative of that is just 2e to the u from 2 to 1. So we get 2e squared minus 2e to the 1. Which really cannot be cleaned up any further. It'll just be 2e squared minus 2e. Last problem. The inside function is 1 minus 2x. So this one's kind of interesting because now we don't have definite numbers. We have a variable in here, and they tell us the whole thing is e to the 4th, and we're going to have to find a in the form of lnk. First thing we're going to do, u is equal to 1 minus 2x, which means du dx is equal to negative 2. Now, I don't see a negative 2 in there, so when we rewrite this, we're going to have to do a negative 1/2 du is equal to dx, because all I see is a dx in there. Then when we rewrite, oh no, we can't rewrite yet. We got to plug in this guy and this guy into u. So u of a is equal to 1 minus 2a, and then u of 0, u of o, go Ducks, is 1 minus 2 times 0, so this becomes 1. Now when we rewrite just this part of the equation, that whole part becomes 1 to 1 minus 2a, e to the u, and then the du is a negative 1/2 on the outside. Now take the antiderivative, which is pretty easy. It just remains itself. Then we'll plug the top thing in and subtract the bottom thing. So this will become negative 1/2 e to the 1 minus 2a, and then subtract a negative 1/2 e to the 1. Now, you guys, the whole part I haven't done yet is that all of this is equal to e over 4. So now we can kind of rewrite this whole part and set it equal to e over the 4, and then we'll try to solve for a. Let's say that this is e 1 minus 2a all over 2. Then the negative negative becomes a plus, and then the e to the 1 is just e, so this is plus e over 2. The whole thing equals this. So now we need to solve this. I'm going to multiply both sides with a 4 to get rid of all the fractions. So that will mean that we have 2e to the 1 minus 2a plus 2e is equal to e. Now we need to solve this. The way we're going to do that is, we can subtract e from both sides because these are like terms. Actually, instead of doing that, let's subtract 2e from both sides. So we get 2e to the 1 minus 2a is equal to negative e, I believe. Did I do that right? I feel like I screwed something up. Okay, now we need to take the natural log of both sides. So we'll get natural log 2e to the 1 minus 2a is equal to natural log of negative e. Now we can split apart this side to get natural log of 2 plus natural log of e to the 1 minus 2a. And then this will just be natural log of negative e. Then we're trying to get the a by itself, so you can use that log property to bring it out in front, and also subtract the, I'm going to do two moves at once because I'm running out of time. I got kids coming in the door in 2 minutes. I'm sorry, you guys. Natural log of e, that part comes out in front. We get natural log of negative e minus natural log of 2. Then this goes away, it's just 1. So we get 1 minus 2a is equal to, gosh, I could smush those two logs together just for fun. Negative e over 2. And then we'll add 1 and divide by negative 2. So a equals natural log negative e over 2 plus 1, all divided by negative 2. You guys, this algebra is really messy. I think there's a way to clean it up to get it in the right form. I'll try to finish this one off in class for you guys. I apologize. Good luck with your homework. Please ask me questions in class.